hello everyone and welcome. My name is Remigiusz Samborski and I'm a developer advocate working at Google, actually at Google Cloud. And today I'm going to be talking about open models. So I've been involved with open source and doing a lot with open source since installing my first Linux maybe 30 or so years ago. And I was always passionate about this. And right now, I feel and I believe that open models will do the same thing that open source did to revolutionize software that we've seen so far. So today I'm going to give you some idea of what open models are and what you can do with them. And I hope you will be able to innovate based on these models with your use cases. So what to expect? First of all, I'm just going to give you a short intro of AI and Gen AI, just so we are on the same level and that everyone knows what we are talking about. Then I'm going to summarize the open models. What are the open models? What to expect from them? I'm going to show you a model garden. That's a tool that we have in Google Cloud that allows you to easily experiment with open models, but also with other proprietary models. And I'm going to introduce Gemma models. How many of you heard about Gemma? I'm wondering. Anyone? Just a couple hands up, right? So I'm going to tell you more about these models. These are our open models released by Google this year, and we are continuously innovating based on them. And I have some thoughts about the future of open models. So I'm going to share them as well, and then I hope for some Q&A if we have enough time to talk. All right. So what is AI? So first of all, we have different definitions of AI. Everyone has their own. And with the hype of LLMs and generative AI, many people just think of AI as generative AI or LLMs. And this is not quite true. And basically, the term AI was coined in late 1950s, by Alan Turing and John McCarthy and a couple other scientists. So that was when they actually coined the term. And AI had their ups and downs during this time. We don't have time to go through the whole history, but basically it had different stages of evolution. But I personally like this definition. This is a definition from 2019. It talks about data. So of course you need data to talk about AI system. And the system will learn from this data and will use these learnings to achieve specific goals or tasks with a flexible adaptation. Flexible adaptation, this is the main difference from the typical algorithms that we would code, because the system based on data is making their own decisions. So in this regard, what is generative AI? So we all know the hype. We all heard about LLMs and the hype that is happening right now. And generative AI is a subdomain of AI. When we talk about generation, text, images, videos, audio, whatever you can think about, this is generative AI. And when you think about generative AI, in most cases, we are using now LLMs to do that. And if you think about LLMs, LLMs are just a neural network that tries to understand the text and tries to probabilistically expect the next word, the next token that we have in our text. So in this example, we can see it's raining cats and naturally we would know that dogs are the right answer. And the LLM has the probability, the very high probability, 90% probability that this is the next word that we are looking for. So basically LLMs are actually autocomplete on steroids. So if you think about your simple autocomplete that you had in your phone, this is just autocomplete, but with much much more data ingested into it. And another example, roses are red, violets are blue, sugar is sweet. Yes, that is something that the LLM would suggest as the next part of this particular sentence. But the important fact is that LLMs are huge. They are really large. They are trained on really big data sets. And they have a lot of parameters. They have billions or even trillions of parameters right now. And thanks to that, they have created something that allows us to prototype really fast. And they have these three differentiators from the previous generation of AI. So the first differentiator is what we call emerging capabilities or emerging abilities. So because of that, the LLM was trained on such a huge data set. it can now generate code. It can translate from one language to another. It can answer questions, yes? And this is all just because we train it on a big data set, and the model is such big that it actually is able and capable of doing that. The second thing that is a differentiator is that right now we are able to use LLMs as a new interface to all our products. So we have a new interface, interface that actually is understandable to most of the users. So just use plain English or plain Polish or whichever language you are using, and you can actually get your system, you can interact with your system. You don't have to learn SQL. You can ask a simple English question and potentially get a right answer. So we hope their answer will be correct. And the third capability is the way it is different from, it is like the third stage of AI. So the first stage of AI was very simple. We had regression, just trying to map our data to some regression function. Then we had bigger models, that neural networks that could understand more from our data set, and they could predict the next thing that should happen based on the historical data. They would predict, based on the historical data, they would predict the future and what is happening. And now with LLMs, we actually have a big model that actually can read from many sources and can understand, can find commonalities between different distributed data sets. So that's the difference, and that is a big differentiator for us, because in the past, if you wanted to build an AI model, you would have to have a lot of data yourself. You would have to train the model on your data and only then try to make predictions. Right now, you can have an LLM that is trained on these big data sets and give it some examples, maybe do a few shot prompting and get the results that you are expecting, a really quick prototyping way of building things. All right, so you know what LLMs are. So what are open models in regards to when we talk about LLMs? So first of all, it's not clear yet, it's not defined yet fully what an open model is. And we have a definition of what an open source code is. Yes, so we know what an open source definition is, and it's based on 4 freedoms: the freedom to run your code, the freedom to study the code, to redistribute the code, and modify the code. But it doesn't really apply to AI, and it doesn't really apply to the models. Therefore, the OSI, the Open Source Initiative, in 2022. They started an initiative to define an open source AI definition. So there is a difference between the open source definition and the open source AI definition. And this definition is still in the makings. Just a week ago, the release candidate number 1 was released for this particular definition. It's been 2 years in working. With many drafts, with many experts from companies like Google, Meta, Anthropic, companies that build these models. They were collaborating to create this definition, and it's not yet released. It's a release candidate. So if you look at the roadmap, it should be released by the end of this month. So maybe next month, if we meet, we actually can say, yes, we have a definition. We know what an open model or open source AI actually is. And this document is constructed in such a way that it not only includes the document itself, but there is a checklist that will allow us to say, okay, is this an open source AI model or is it not, based on these several components. And the checklist currently includes 17 components. There are 10 components that are required components and 7 components that are something in addition to these 7. And here on this slide, I'm just presenting the checklist as it is. This is the version 09 from the draft. I should have updated it to the release candidate. I don't think there were many changes. But basically, what you can see here is that we have these areas. So there is an area of data. Yeah, my pointer doesn't show here, but you have data at the top. And several things related to data. You have code and you have the model. In open source code, it was simple. You had just code, maybe some assets. In regards to AI, you actually need to have more information about the data that was used to train the model. You need the code to understand how the model was trained and the actual model. And in reality right now, if you are talking about open models like Llama, Gemma, and so on, usually what is meant is the open weights model, which means that only the last part, the model part, is open. We know the architecture of the model, and we know the parameters. We can access openly the parameters. We can modify the parameters. But we don't really know much. Yeah, probably a research paper is something that we can access, but we won't know exactly. We may not have access to all the data sets that were used to train this model, and we may not have access to the code that actually was used to train the model. So hopefully with this initiative, we will have more models that actually allow us to have more in-depth look into how they work actually. But you may ask yourself, what is there for me? Yes, like, what is there for me? Why should I care about the open models? Why cannot just use the models that are freely available or available on the cloud or via APIs? So there are a couple reasons. So first of all, customization. With open models, you have access to all the weights. So you can either fine-tune it, but you can modify the model completely. So you can actually customize to your particular use case. And I'm going to show you a couple demos later how you can actually do that and how you can actually customize your model. The other thing that is very important here in Europe, the security and privacy of your data and what your model is doing. So with open models, you actually control the deployment, you control the data access, you control who can use the model. So you can make sure that no one outside of your company has access to it, and that no data will be sent somewhere else, which is a very important thing in terms of GDPR and the laws that we have in Europe. The other thing is community support. So there is a big community of people who are actually extending these models. They are building their own models on top of the existing ones. So you can actually find a model that matches your use case, or maybe was built for your particular industry. So this is big. On the other hand, on the flip side, these models don't get enterprise type of support. So if you are looking for enterprise support, then you would have to go to one of the big players and actually have a proprietary model that they share via APIs. The other benefit is they are available in different sizes. So I will show you later that with different sizes there are differences, and maybe in your use case you don't need to have a huge 70 billion parameter model. Maybe a 2 billion model will be enough. Yes, so depending on your use case, you can choose the model, and of course the smaller model will be less capable, but it will require less resources to run. It will cost you also less to actually deploy it, to run it. And one thing that is also a huge benefit of using these open models is that you can actually deploy them on-premise in a contained environment, or you can deploy them on edge or even on your devices, which means that no data is sent through network. Again, this goes to the security and privacy. And today on the keynote, the Devox Genie that was presented, it actually was using a local model, the local Llama model, and you could be sure that your code is not going outside of your workstation. All right, so how to start? How to actually start using these open models? So there are different ways to do that, but I'm going to recommend you one of the ways that works with Google Cloud. So this is a model garden. I don't want to show you only the slides, so let me just show you how it works. So basically, in Google Cloud, you have a tool called Model Garden. It's as the name suggests, it's a garden where you can find different models. And if you are interested in particular ones, for example, from our partners, let's say I'm interested in models from Meta, I can just view all the available models from Meta. And let's say I'm interested in Llama 3.2. What I can do is I can open it. I have to review the user agreement, user license. Yes, I should probably read it before agreeing to it. So let's assume I read it earlier. What you can see here is an overview page of what is this model, how it was trained, what is the architecture of the model. Yes, you can see different versions. So there are one billion parameter model and 3 billion parameter model. For some of the models, especially the ones that we are partners with, you can actually test it out here. But the main feature of this solution is that you can actually deploy it from here. So we can click deploy, and we can then select the actual model that we want to deploy, where we want to deploy in which endpoint, and the region that we want it to be deployed to, and also the specification of our machine. And I would just click deploy if I provide all the parameters. Yeah, I probably don't have quota for this particular one, but assuming I would have quota for this one, I could click here deploy. It would take several minutes, and then I would have an API, like a deployed endpoint, which I can call with APIs. And I can also see the sample requests, so I can see what kind of request I would need to use to actually call this this model. And these models can be deployed on Vertex AI directly. This is our managed API managed platform that is used for ML and AI. But you can also deploy it to Google Kubernetes, and you will get a spec YAML file that you can use to deploy this model in your Kubernetes cluster. So you would just copy it and follow the instructions. So there are these are the two main ways of installing such models. But we also have let me close that. We also have the ability for some of the models. And there is a list. So they are called API service. This is what we call model as a service. So for this particular model, you don't need to deploy it anywhere. You just enable it. And then when I click enable, I will get an endpoint, and then I can just freely call this model, and I pay as I go. So I only pay for the usage of this particular model. And actually, this one is in public preview, which means that I can use it for free, at least right now. Yes, so you can actually use it for free without any additional costs. And if you scroll down here, you can even see how simple it would be to call it. So you just need to update the project ID. This is the ID of the project that I'm in. And then you can freely call it with, there's a curl command here, but you can, of course, call it with any tool that you would like to use and call your deployment here. So that's for Model Garden. And then moving on to the Gemma open models. So Gemma is a family of models that was built on the same research as Gemini, our foundation model that is right now being used in many Google tools, and it's being made available to all the users. But it's an open model. So we released it in February, which means that you can now download it, play with it, fine-tune it, whatever you want, and just use the model that Google have created. And it's a family of models. It's not a single model. I will just in a moment show you that there are several different variants of this particular model. And so how to get access to Gemma? So first of all, you can use Vertex AI, as I just showed you in Model Garden. If I go back to Model Garden, I could just deploy Gemma from here. So it would be all right. Yeah, I have Gemma 2 here, and the same way I need just to agree with the terms and services, and I could just deploy it from here to my Vertex AI endpoint. So that's one way of using it. The other way is to go to Kaggle or Hugging Face and download the model and deploy it locally, deploy it on your cluster, or just run it locally. So whichever way you choose, you just need to agree with the terms and services, the license, and then you can freely use this model. And as I mentioned, there are different types of Gemma. So first thing to decide is the size of the model that you are interested in. Yes, so there is the 2 billion, 7 billion, yes, the 2 billion, 7 billion, and 70 billion parameters versions. So depending on your use case, you would choose a different model. But what is also important, there is a version that is already fine-tuned. It's called instruction-tuned version. The instruction-tuned version is made in a way that it will follow your instructions. So if you are building a chatbot, if you are building a solution and you want it to follow instructions, the instruction-tuned version is the first one to try. The one that is not instruction tuned, it requires fine tuning because it's just made to do the kind of autocomplete. So if you start writing to it, it will try to generate text that follows like the next words that would follow your text. So it's not really well suited for tasks. The instruction tuned version is well suited for tasks. So this is one thing that you would have to think about. But there are also different variants of Gemma, and that's also interesting to based on your use case. You may actually want to use one of these models to support you, so you don't have to fine-tune it yourself, but you can take one that is already fine-tuned for your use case. So we have Code Gemma. This is a version that was fine-tuned for code completion. And for example, if you were playing with the Devox Genie that was presented today, you probably would use this one as the first choice to just see how it works with code completion and how it can help you with your code tasks. So that's one of the things you can consider. Then we have something called recurrent Gemma. So if in your use case the efficiency, the throughput, like how fast the tokens are being generated, how fast you are able to get answers from the model, and also the memory footprint are important for you, then you would use the recurrent Gemma. This is the version that is optimized for throughput and also to have a smallest footprint in the memory. We also have a PalyGemma. PalyGemma is a lightweight open vision language model. So if your use case needs to analyze images, answer questions based on images, compare images, things like that, then PalyGemma would be your choice as it's specifically trained to focus on tasks related to images and vision. Then in the middle, so these three models were released in the beginning of the year. So the original Gemma was released in February. Then the Code Gemma, Recurrent Gemma, PalyGemma were based on the first version of Gemma. But then we did, based on the learnings, we released Gemma 2. The architecture was redesigned. And Gemma 2 was made available in June this year. And based on Gemma 2, so Gemma 2 is the generic model that is capable of doing different things. But based on Gemma 2, we also started developing other models as well. So there is a Shield Gemma. This is a version that is specifically trained to catch any harmless behavior. Like if your model is answering with some things that you don't want it to answer. So Shield Gemma is the one that you could use to check the responses or the input of the users if they are trying to do something harmful. And this model can help you actually navigate that and block these kind of requests. And the newest version of Gemma is Data Gemma. It was released actually in September, around a month ago. And this is an approach to try to avoid hallucinations. As some of you may know, hallucinations are a big problem in LLMs. We are having a tough time to tell if they are hallucinating or not. Data Gemma is using Google Data Commons library. This is a big database of all data points that are made available by public institutions like health institutions, World Health Organization. So when you ask Data Gemma, it will try to ground its responses in that data. So if you are asking how the world population changed over this time of period, it will reconstruct its responses in such a way that it will pull the data from this database to make sure that the data is valid. Okay, so quick demo. I showed you that you can use Gemma in Vertex AI Studio, but it requires you to deploy it, and then you have to call the APIs. But the simplest way to just start playing around with it is via Google AI Studio. And Google AI Studio just requires you to log in with your Google account. Yeah, so I'm logged in here with my presentation account, and then I can start asking questions, and I can try to use one of the Gemmas. So we have 2 billion, 9 billion, and 27. This is Gemma 2. So we have 2 billion, 9 billion, and 27 billion parameters versions, and I can just start prompting why is the sky blue? Yes. So that's one of the things I could just do, and it will measure the time and show me the results of this particular question. But what is interesting here, you can actually compare models. So if I go here and compare, I can compare the different responses from 2 billion parameters version with 27 billion parameters version. And let me just clear the chat. And let me ask the same question. Why is the sky blue? Yes, and as you will notice, usually Gemma, the smaller model is faster, but it may not be so detailed in answers, or it may not be, the answer may not be so valid. So you have to test on a particular use case. So this one took 4.3 seconds. This one took 6 seconds to generate the response. We would have to compare if both of these responses or which one is better for our particular use case. But you can actually start playing without a need to deploy anything on your and use any resources with this. All right, but there's more. So Gemma is integrated with Keras. Keras is a framework that is simple. It simplifies development. It simplifies using the models. It's flexible. It offers you many different things like fine-tuning of your models, adding additional data to find when you fine-tune it. And it also is very powerful because it's extendable. You can build on top of that, and Gemma of course supports that. Yes, so we made Gemma available for Keras, and Keras understands how to work with Gemma. So I will show you how to use this. It's the simplest way to use it is in a notebook, and I know most of you might be focused on Java. This is actually in Python, but that's what we have right now in terms of fast prototyping, fast building things in this space. So this is the notebook that is actually linked in the presentation. I have it already opened in my collab. I just probably I need to reconnect my runtime. So while it's reconnecting, this is just I open it directly from GitHub. The thing that I would like to change is it by default uses the 9 billion version of 9 billion version of Gemma. I'm going to change it to 2 billion just so it loads faster, and this runtime I have connected probably wouldn't be capable of running the 9 billion one version. So that's one thing. The other thing that is important here is that I need to input my Kaggle secrets. So I have my Kaggle key and Kaggle user already in the notebook, so that it can be read from here, and it will be used to pull the Gemma. And what I had to do before that, I just had to go to Kaggle with my account and mark that I read the terms and services and that I agreed to the terms and services, because otherwise it would not work. Yes, so there are a couple of things I needed to do beforehand, but now as I do it, I can just start running it. This is just setting up some parameters. This is installing dependencies, so not really interesting. The interesting part starts here when I actually import the Keras. I set some parameters, and this is the line that actually imports the model and downloads the model to my workload, and it will be able to run it then locally from this server that is running this notebook. So it takes around a minute to download the model and prepare it for execution. So, and then let me already run that so we can wait and see how it's gonna react. So first it's going to download the model, show me a summary of the model, and then it will call the generate function, which will generate the answer to this prompt. And notice that this is the version that is not instruction tuned. If it were instruction tuned, it would have something like -it at the end. Yes. If it doesn't have the -it, it's the generic version, which means that it will try, when I call this prompt, it will just generate the next tokens based on this text. The interesting thing here, if you look at the summary, because the model is already downloaded, and I can see the summary, you can see how many parameters the model actually has, because it's called 2 billion, but it actually has 2,600,000, 600 million parameters. And you can also see the size of the model. So unpacked model is around 5 gigabytes of data. And you can also see how many parameters are trainable. So you see like all the parameters are trainable. So you basically can redo the whole model. You can, when you do fine tuning or you make it work for your use case, you have access to all the parameters that the model has. And here I run the model and I see all the text that it generated. So yeah, I think it fell in some loop because it's starting all over again. Yes, you can see it's running in kind of loop. Like if I use the instruction tuned version, it would be probably better for like calling some questions or asking it to do some particular tasks. All right. Going back to the demo, and there is a little bit more. So we also encourage everyone to join the Kaggle community, because the Kaggle community is the place where many people experiment with open models. They publish their own models, they publish the research that they've been doing or some ideas that they have. And there are also competitions. So every now and then, Kaggle or Kaggle with partners run competitions. There is a specific task to be solved, and if you are able to solve it with one of the models or build your own model that solves it, you can win. We can win great prizes. And there's also a community forum, so you can use it to ask questions, to see what other people think, and innovate based on these models. And I already mentioned that you can fine-tune the Gemma, so here are links to how would you do it. You can do it with Keras. That's the simple path. That's the high-level API that's much easier to understand and much easier to use. But you can also use JAX. JAX is more low-level API. This is something that we've been developing at Google for some time ago, for some while already. And if you're like a really hardcore data scientist, you want to really pinpoint what is happening, then I would recommend to use the second one with JAX. And once you already have your Gemma fine-tuned, once it's ready, you can deploy it in different places. I already showed you Vertex AI, GKE, but you can also use it in your data flow pipelines. So if you have data flow pipelines for any other solution, you could directly use Gemma there. And I want to show you a demo of what you can achieve with fine-tuning. So one of my friends had an idea like, let me use Gemma and fine-tune it to speak like Yoda. Yes, she's a Star Wars fan, so let's see what we can do. And I actually have this model that she fine-tuned. I have it deployed here on one of the endpoints, so I will just show it to you here. So this is the Google Cloud Console. If I go down, I should have the online predictions. And I need to change the region. It's US West 1. So as you can see, I have this Yodify on Vertex endpoint. This is the ID of my endpoint, and I will use it. I have a solution. I have a code. It says also Python actually, but it's. The important thing is here in the environmental variable, I just set the project ID and the endpoint, and then I can start calling this particular model that is deployed in the cloud. Of course, I have some additional code that actually calls it, but we don't have to go for that. I just wanted to show you that this particular model is in vertex here, this number, and this number is the same number. So this is the same. I'm actually calling this model. And the solution is deployed on Cloud Run. So let me just refresh it. Sometimes Cloud Run goes to sleep because it's a like serverless solution that just scales down to 0. So if I haven't refreshed it for a while, it will just scale down, and I need to refresh it. All right, now it's running, and now I can just start chatting with it. So let me just ask some maybe career questions. Yoda would be a good, wise man to talk about my career. So as you can see, the answer, career path, different is for each person. Choices many there are. Yeah, so you can see that it is actually responding in a way that the mentor would do. And the thing is that we were trying to jailbreak it. It's not really easy. Yes. So if you have a model that you just have a system instruction telling it do this, it's quite easy to jailbreak it and remove the system instructions. For this particular one, when it's fine-tuned, it is not so easy. So I can ask him more questions like, how do I make a decision? Yes, and again, it will use this this weird way of speaking that Yoda would, and you can freely chat with it. It's a fine-tuned model based on Gemma 2. Right. So that concludes the demo. And one more thing I wanted to show you is how you can actually deploy Gemma on devices. So to do that, you would need to use two tools. One is the TensorFlow Lite. It's a framework that converts your models. It can convert a TensorFlow model, or it can convert a Keras model to TensorFlow Lite. It will do optimization, quantizations, all other fun stuff, just to make sure that the model is small enough to fit on a device. And then you can start using it on the device. The other thing you need is MediaPipe. MediaPipe is a framework that allows you to chain these models. So you can chain several models, but even if you are using one model, it allows you to do what's the word? You need to manipulate your data before and after it's calling the model. So it allows you to do this. And pre-processing, it's on the slide, exactly. And you have a couple examples here that you have examples in MediaPipe repositories that show you how to do these things that are here, but you can also use it to call LLMs like Gemma. So you may ask yourself, like, why should I care? Why should I deploy it on device? And what it can do on the device. It can do basically the same things it can do in the cloud, but you will not pay any cloud bills. You will just, maybe your battery will die faster. You will not have any privacy concerns. It will not send any data out of your device. And you can use it without connectivity. If you are in a place where there's no Wi-Fi, or you are on the train, the Wi-Fi is very choppy, you can still work with this LLM and innovate or brainstorm some ideas. So we have demos and available. Like, so the first one is actually a demo that you can just go to this URL and run it. I'm just going to quickly show you how it works, and I'm going to prove you that it's going to run without any internet needed. So this is the simple interface, and what I need to do is I need to select a model. And I already downloaded the model, so I'm going to open it here. This is the Gemma 2 billion version with this IT, so it's instruction tuned, and it's dedicated to GPUs, and it's also quantized to int4. You have also versions quantized to int8. They will be more capable, but they will also take more space. And as you can see, this model, after quantization, after doing this making a TensorFlow Lite modifications, it takes only 1.3 gigabytes. So let me start uploading it. Compared to what we've seen in this notebook, it was almost 5 gigabytes. Yes, so it's 4 times smaller than like the raw model that you would use. So it's loading the model. Okay, the model is loaded. Just to show you that it's running on the device, I'm going to open Developer Tools. And I'm here in the Network tab. Let me just say I'm offline. Yes. So now no internet in this particular tab. Let me open the console, clear it, and we can start asking questions. So we ask the question about sky. So why is the sky blue? Again. And you can see in the console that it's calling the inference, and you can already see it's responding. Yes, and there is no internet connection here. Yes, so I'm completely offline. Yeah, it cached some font. It took it from cache, but there was no internet. This model is running on the device on my laptop, and it's pretty fast. Yes, so it was able to respond quite quickly. Nevertheless, this is the smallest version of the model, so if you ask it more complex questions or more complex queries, it may not answer in such a good manner as a bigger model would. So you can also use the same approach with MediaPipe and TensorFlow Lite on Android, iOS, or web. I just showed you web, but we have examples for different operating systems. So this is the repository you would clone, and once you do that, you have to go to the folder that includes this particular example. If you click on these links, or later just take a screenshot of these, you will be able to directly go to the particular folder with this particular example. And what else do you need? So you need the model, yes? So as I mentioned before, you would download the model from Kaggle. And in Kaggle, there are a couple different versions of the model. So you would go to the TensorFlow Lite version, and then you can see here and experiment also with different versions. So I was using the GPU int 4 version, but as I mentioned, there is also GPU int 8, and there are also CPU versions. Yes, of course, with AI, with LLMs, GPU is going to work faster, but maybe you have a device that doesn't have a strong GPU and you cannot use it. So then you could fall back to the CPU version of the model. So the first thing you do is you have to download the physical model. Then if we are talking about Android, you would have to just go, once you clone the repo, you have to sync your Gradle just to make sure that everything is being read. And then you would go to the code snippet that is part of the main execution. And there you can see here there is the set model path. And this is actually Kotlin, so that's closest to Java I get in my presentation today. So you have to set the model path, yes, and here you would pinpoint to the model that you just downloaded, yes. The important thing is that you downloaded your model to your device, probably your computer. So now what you need to do is also use ADB to push the model to the device. Yes, this is for your experimentation purposes. Like if you imagine you have an application that wants to use a local model, you would have to figure out a way to get the model to the device. Sorry? Yeah, that's also possible. I don't know if you can get one like that still, but yeah. But assuming you have like customers or users all over the world, you wouldn't send them SD cards, yes? So you would have to figure out a way to download the model. Maybe when you first start the application, you download the model so it's locally available for them in the future. We don't recommend putting it as part of your application because it just bloats the application, and whenever you want to update the model, you have to update the whole application and so on. So the best way is to figure out a way to download it when the application starts. And then when you run it, I don't have it installed on my phone right now, but here's a short like screencast. This is what would happen. Yeah? So you can just ask questions and you will get answers. And as previously shown, this will happen on the device. So it will not call out to the internet. It will be calling this model on the device itself. All right, so a couple just words about the future of these open models. And I just say this is my personal view on that. Views may differ. But first of all, one thing that I think it's going to happen, and we are close to there. This OSA AD, so the open source AI definition, will get finalized. It should be finalized by the end of this month. It's going to be published, and we will start adopting that. So we'll see how the adoption goes, and how many companies actually follow that. Then we will see more and more models appear on the market. Even with Gemma, you saw there are already 6 different variants, but people are experimenting, releasing their own models, building on top of these models. So the space is growing, and it's growing really fast. So there's going to be more and more models available from big players, but also from the community. And based on the community innovation, this will also trigger new models, new ways of using them, new ideas will pop up as with open source. So like we build on top of each other's solution. We have libraries that we can use, and we can build new libraries based on them. So the same thing is already starting to happen with the models. We will see more fine-tuned solutions. We already see that there are some solutions that are made for particular tasks. So it may happen that if you are working in a particular industry, you will already see several open models that tackle similar problems that you are trying to tackle. And instead of spending time fine-tuning, making your own models, you can just reuse what someone else has created before. And that's a very big open question, like what innovation will come from the on-prem, on-edge, or on-device deployments, because that's something that's going to grow. More and more people are aware of that, and more people will be building use cases, building software that is actually using these models on the device. All right, I'm on time. We have still 3 minutes, so I have time to answer some of your questions if you have those. Just feel free to raise your hand or shout the question. Yeah, sure.
You mentioned that they're working on an open AI, open source AI definition.
Mm-hmm. Okay, so to repeat the question, thank you. Great question. So the question is like that the OSI is working on the open source AI definition, and how Gemma will apply this definition to itself. So yeah, that's a good question. I don't really know the answer. That's up to the decision makers who will be releasing this model. So right now we apply only to this bottom part, the model part. Yes. So we open the weights and we open the architecture. I'm not sure how open in the other areas it will be. There might be some versions that will be like fully open, but that's not something I can predict at this time. Welcome. Any other questions? All right, and thank you very much. If you are interested to know more about Model Garden or Gemma, these are the links you can go and explore to read more about Gemma and Model Garden. And just wanted to thank you. If you'd like to connect with me on LinkedIn and ask additional questions or just stay in touch, please do so. I'm always open to talking and understanding problems and use cases that people are having with these solutions. Thank you very much.
All systems are nominal. Initialize Genesis